Math 70, section 9.4. In this section, we're going to simplify radical expressions using some of the properties of radicals. So the first property is what to do when you are multiplying radical expressions. Can you multiply them or not? Well, you can multiply them, but right now what you need to watch is that the indexes are exactly the same. So the first rule, it's called the product property of radicals. When you're multiplying radicals, okay, you want to make sure that the index is the same. So if I said, what's the square root of 4 times the square root of 9? You can do this, you can say, you can put them both underneath the same, 4 times 9, and then take the square root of it. So if the indexes are the same, so these are both understood to be 2, you can merge them together under one radical, and then go ahead and do square root of 36, which is 6. If you want to keep them separate, square root of 4 is 2, square root of 9 is 3, and 2 times 3 is 6. Okay? So the first rule is the multiplication of radicals, and all you do is multiply the radicands and you keep it all under the same radical sign. So for A, the square root of 5, we don't know what it is, times the square root of 3, we don't know what it is because these are irrational numbers. We can simplify this as the square root of 15, because 5 times 3 is 15. For B, B now is asking you the cube root of 2, and what that means is what 3 numbers are the same that multiply to give you 2. We don't know what it is. We're not going to worry about it right now. So this is asking you the cube root of 2 times the cube root of 13, simply just because these indexes are the same, cube root of 26, because 2 times 13 is 26. For C, we can just multiply x minus 3 times x plus 3, and that you would just FOIL x minus 3 times x plus 3, x squared. 3x minus 3x is 0x, and then minus 9, and then leave it underneath one radical sign. And then D, B, these are both the fifth root, so just simply multiply 6c times 7c squared, and that would be the fifth root of 42c to the third power. You add these exponents. Okay? Okay, next, moving on. All right, now this is important. This is how are we going to simplify radical expressions. Okay, here is how you're going to simplify. So example 2 says the square root of 18. So what I would do is I would take the number 18. Since it's not a perfect square, I don't know what 2 numbers multiply to give me 18. And it's not 9 plus 9. It's what 2 numbers multiply. So let's break up 18. 2 times 9 is 18. 2 is prime, but 9 is 3 times 3. So what we're going to do is break 18 up into 2 times 3 times 3. So now we're looking for 2 of a kind, 2 factors that are the same. There you go. You've got this 3. So the 3 comes out, this 3 comes out, but that 2 has to stay. This is what simplifying radicals is all about. Okay, now because the index is 2, we're looking for 2 of a kind. Let's do some more examples. Do we even have any more? No, we are going to do these ones. Example 3. Example 3 is, this one asks, it's saying 5 times the cube root of 24. So now this 5 is separate. You're gonna do this first. So let's look at cube root of 24. If I were to take the number 24 and break it up, 2 times 12 is 24. 2 times 6 is 12. And 2 times 3 is 6. So 24 is 2, 2, 2, 3. These are the factors of 24. So now what does cube root mean? It means I'm looking for 3 numbers that are the same, which is 2, that multiply to give you whatever. In this case, it would be 8. So this 2 comes out, but this cube root of 3 stays because we don't have 3 3s. But now don't forget there was a 5 standing outside. So now we can multiply 5 times 2, which is 10, and then cube root of 3. So this is the answer simplified. Okay, let's do another one. Square root, now we're back to 2 of a kind, 128x squared. So now I want to break up 128. 128 is 2 times 64. Now I could say I know what the square root of 64 is. It's 8 times 8. So you don't have to keep going. If you want to, you can. But this is 2 times 8 times 8. Now, and then we have 2 x's here. So what 2 numbers that are the same? These 2, and also these 2 x's. So this 8x comes out, but the square root of 2 stays. Now, we are also going to keep in mind what we learned in that previous section. When you're dealing with a variable and it's even, it's an even power and the index is even, you are going to put absolute value on it. We want to make sure that this number is going to be positive. Okay? For C, square root of 20, fourth root of 20. So fourth root of 20, I am looking for what 4 numbers multiply to give you 20. So 20 is 2 times 2 times 5. And since there are not 4 factors here, we're going to leave this as the fourth root of 20. That's as simplified as that answer could possibly be. So a few more examples, because I think we need practice on these. Square root of 48. So if I broke 48 up, 48 is 6 times 8 is 48. 6 is 2 times 3. And 8 is 2 times 4. And 2 times 2. So 48 is 2, 2. I'm putting them in order. So there's 4 2s. 1, 2, 3, 4, and a 3. These are all the factors of 48. So now I'm looking for 2 numbers that are the same. Well, there's 1 and there's 1. So these 2 2s come out. 2 times 2 is 4, and that 3 is going to stay. Okay. Example 9. I have 4 cube root 54. Well, 54 is, we can say 2 times 27, and 3 times 9, and 3 times 3. So do you see, here are your factors of 54. I need 3 of the same. Here's 3 of the same right here. So these 3's come out. 3 times 4 is 12, and this 2 has to stay. But make sure you keep, a lot of students forget to keep that radical, that index. Make sure that it's cube root, that 3 has to stay. It doesn't have to stay if it's a 2, but 3, 4, 5, anything above 2 has to stay. And what was remaining is this 2. Okay? For 10, we have square root of 200a squared. So now, 2 times 100 is 200, and 100 is 10 times 10. I'm just looking for two numbers that are the same. Here's 10, and here's two A's. So this is 10A, but don't forget absolute value around that A, and then the square root of this 2 stays. And 40, I know, is 4 times 10. And I know that I'm not going to be able to get 4 of the same anything, so that's already fully simplified. Okay, example 4. This has a fraction, 4 minus the square root of 20 over 2. This can be simplified. So I'm going to take off to the side, square root of 20 is 2 times 2 times 5. I have a set of 2's. The 2 comes out, the 5 stays. So this problem gets to be 4 minus 2 root 5, because square root of 20 is 2 root 5 over 2. Now, when you have a fraction, this denominator goes under that, and it gets shared by both of those. So it's 4 over 2 minus 2 root 5 over 2. You can continue to simplify this. 4 over 2 is just 2 minus, these 2's cancel, and keep the square root of 5. Okay, example, we're going to do a couple more of these. We need practice on these. So for 12, we have 6 plus root 45 over 3. So off to the side, square root of 45 is 3, 3, 5. Okay, so because 9 times 5 is 45, take out the 3. So 45 is really 3 root 5. And let's leave all this other stuff here. So now 3 goes into 6 2 times. And this 3 and this 3 would cancel. So it would be root 5. So make sure you understand you're sharing this 3 with both of these. Do not cross these two 3's out and then say 6 plus root 5. This 3 is under both of these. And number 13, we've got negative 2 plus the square root of 32. If we look at square root of 32, square root of 32 is 2 times 2, which is 4, times 2 is 8, 16, 32. So if you make a factor tree, 2 times 2 is 4, and then square root of 2. Now, simplify. This is negative 2 over 4, which is negative 1/2. And then the 4's would cancel, because remember, this 4 is under both of these. So it's 1/2 plus these cancel, square root of 2. Okay? All right, so here is, make sure, we're just going to repeat when you use absolute value. If these are both square roots, you're going to use the absolute value. But if the index is odd, if they're odd, if n is greater than 3, you don't have to use the absolute value. Okay, so here's like, this means that if you took the square, if the variable is squared and it's square root, it's the absolute value. But if it's cube root, you don't. If it's 4th root, you do. If it's 5th root, you don't. If it's 6th root, you do. So so you use the absolute value when they're both the same like that. So keep it simple. So for this next one, square root of 20 x to the 5th. Okay, I'm sorry, x to the 10th. My bad. Square root of 20 x to the 10th. So I need to break this 20 down. 2 times 2 times 5, and we have 10 of these x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you don't have to write this all out, but this is a visual to show you that you've got 10 x's. So we're looking for two of a kind. There's two of a kind. There's another one, another one, another one, another one, and another one. So we have a group of twos, and we have 5 groups of x squared. So it's x to the 5th power. Now we're going to leave that 5 underneath because there was nothing to pair it up with. And that's what your answer ends up being. Okay? Next one, we're going to do square root of 75a to the 6th. So 75 is 3 times 5 times 5. And then you have how many a's? 6. And we're looking for two of a kind. So there's 2 5s, and we have 3 groups of a's. So this is a 5 comes out, a cubed comes out, but that 3 stays under the radical sign. Okay. Example 6. Example 6. We have square root of 80 a to the 3rd. So 80 is 2, 2, 2, 8 times 10. So if we made a tree, 80 is 8 times 10, and 8 is 2, 2, 2. You can start to think of it as that. 10 is 2 times 5. So 80 is 1, 2, 3, 4 2s, and a 5. And then there's 3 a's, a. So we're looking for two of a kind, and we have 2 a's. 2 of a kind is square root. So 2 times 2 is 4, and an a. But this 5a had no match. So we keep 5a underneath the radical. For B, it's saying cube root of 27m to the 4th, n to the 14th. So 27 is 3 times 3 times 3. We have 4 m's, and we have 14 n's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we're looking for 3 of a kind. Well, there's 3 3's. There's 3 m's. And we have 1, 2, 3, 4. 4 groups of n's that are 3 of them. So the 3m, this 3 comes out, m comes out, and n to the 4th power comes out. But what stays is this m and 2n. So we're going to leave it the cube root of m n squared. Looks like an ugly answer, but that's it. Let's make sure, and we are correct. Let's do a few more of these. So 15 is saying square root of 18a to the 5th power. 18 is 2 times 3 times 3, and we have 5 a's. So we're looking for 2 of a kind. We have a 3, and we have 3 a's. So this 3 comes out, and this a group of 3 a's come out. But what stays is 2a squared. Now 16 has a negative underneath the radical, but it's cube root. You can take the cube root of a negative number. 3 numbers that are the same, it's only if it's an even index that you can't. So we're going to, this is really cube root, this is really saying -1 times 128 x to the 6th, y to the 10th, sorry. So what 3 numbers multiply to give you -1? That'd be -1. So that's that. We're going to deal with that right off the bat. 128 is 2 times 64. And 64 is 8 times 8. And 8s are 2, 2, 2, 2, 2, 2. So, how many 2's do we have? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. We have 6 X's and 10 Y's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now there's a shorter way to do this, but I'm trying to simplify this for trying to appease everyone here. So what 3 numbers are the same? We have 2 groups of 2's, and we have 2 groups of X's, and we have 1, 2, 3 groups of Y's. So what comes out next to this -1? We have -1 still. We have 2 times 2, X, X, Y, Y, Y. So really this is -4x squared y cubed. What stays would be the cube root of 2y. So this answer is -4x squared y cubed, cube root 2y. These two, the 2 and the y, we don't have enough 3 of a kind for them. So these are like leftovers. Okay. And the last one we're going to do together here is the 4th root. What 4 numbers multiply to give you 16, a to the 5th, b to the 11th? So 4, we're looking for 4 of a kind. 16 is 2 times 2 times 2 times 2. And then we have 5 a's and we have 11 b's. 3, 4, 5, 6, 7, 8. Whoops, 8, 9, 10, 11. So we're looking for 4 of a kind. 4 2's. We have 5 a's, but we're only going to take 4. And then 4 and 8. So what comes out? A 2 comes out. An a comes out. 2 b's comes out. B squared. But what stays is an a and b to the 3rd, because there's 3 leftovers. Now the other way, the shortcut way you could do this is you take, see this says a to the 5th power. Here's what I would show in class, if we were in class. This is a to the 5/4 power. You take this, this is the numerator, this is the denominator, and that is the same as 4 goes into 5 one time with 1 left over. So 1a comes out, but 1 stays underneath. And then look at b to the 11th power. This would be 11 over 4, which is 2. 4 goes into 11 2 times with 3 left over. So there's 2 full b's that came out, but 3 left over. Okay, so that's another way you could do it. Example 7. We are now going to mix these by multiplying. So for a, square root of 3 times square root of 15 is really square root of 45. Or now you've got to simplify this. This is 3 times 3 times 5. Take the 3 out and leave the 5 underneath. Now the other way you can do it, keep these, I like to keep these separate when you're multiplying. You break 3 up, you break 15 up, 3 times 5 is 15. Here's 2 of a kind, because you're only when you're multiplying can you do this. You pull these 2 3's out and leave that 5. For B, we've got 3 times the cube root. 4x is 2x, and cube root 2x, x, x, x. So I'm breaking this up. We've got 4x, which is 2x, and then 2, we have 4 x's here. Now because these indexes are the same and we're multiplying, we can reach over here. I have 2 2's here and a 2 here. So there's 3 of them. So that 2 comes out. I'm going to merge it with this 3 to give me 6. 3 times 2 is 6. So these are all gone. Now I'm looking for 3 of a kind. I have 3 x's here. I have 2 leftovers, 1 on each of these, but not enough to make 3. So I'm going to pull the x out, but I have to put these 2 together. So it's cube root x squared. So 6x, and then this x came out, these 2 stayed. And for C, now we're looking for 4 of a kind. 4th root, we've got 27. 27 is, 3 times 3 times 3. We've got, let me start over here. Okay, so (27) a squared b to the 5th. And this one I'm going to do it in a shortcut sort of fashion, because it's going to get ridiculous writing all these letters out. So we've got, we're going to merge it all. 27 times 6. How many a's do we have total? Because we can combine them. We've got a squared a to the 3rd, which is, we've got 5 a's. We add these, when bases are the same and you're multiplying, you add the exponents. And you've got b to the 11th power. So 5 and 6 is 11. I'm looking for 4 of a kind, okay? Based on that previous example I did up here, we've got a to the 5th, b to the 11th. So I've got 3, 3, 3 gives us 27, and then 2 times 3 is 6. So here is 4 threes. I'm looking for 4 of a kind. So that 3 comes out. These are accounted for. That 2 has to stay. So I'm going to put 4th root 2. Now I've got 5 a's. I'm looking for 4 of a kind. I have one group of 4 a's, but 1 a has to remain. And I have 2 groups of 4 b's, but I have 3 that are going to stay. 3, 8, 9, 10, yes, 3. So that's that answer. Next, let's do a few more of these to get better at them. So for 18, it's saying square root of 6 times square root of 8. So 6 is 2 times 3, and 8 is 2, 2, 2. I'm looking for 2 of a kind. So there's 2 2's, and I can partner these 2 up to make another 2. So 2 times 2 is 4. That 3 remains. For 19, you've got cube root 12a squared times the cube root 10a to the 4th. So I've got a 12 times 10, and then I've got 6 a's. 2 and 4 is 6. So I'm looking for 3 of a kind. So 12 is 2 times 2 times 3, and 10 is 2 times 5. So look, there's 3 2's right there. So these 2's come out, but this 15 has to remain. 3 times 5 is 15. And now, I need, how many groups of 3 a's? I've got 2 of them, because 6 over 3 is 2. Nothing remaining for a's. And the last one, number 20. Okay, we've got 4 times the cube root 8a squared b to the 5th times cube root 6a squared b to the 4th. So it's 4 cube root an 8 times 6, and we've got 4 a's, so a to the 4th, and then we've got 9 b to the 9th. So I'm going to break up 8 is 2, 2, 2, and 6 is 2 times 3. I'm looking for 3 of a kind. There is 3 of the same number, which is 2. So 4 times 2 is 8. This 6 has to stay. 2 times 3 is 6. Now I need 3 of a kind. I have one group of A's, one group of 3 A's, but 1 A stays. And 9 over 3 is 3, so B to the third power. There's 3 groups of B's. Okay, next. Example 8 is the quotient property. When you're doing division, simply, and the index is the same, you're going to just simplify the numerator and simplify the denominator. Do them separately. Okay, so square root of 18 over square root of 25. Well, 18 is 2 times 3 times 3, and square root of 25 we know is 5. I can take these 2 3's out, leave the 2, and leave the 5. Square root of 25 is 5. Now, if these 2 were divisible, if we could simplify that, we would do that. For B, it's asking you cube root I need 3 of a kind. Cube root 6z cubed over cube root 125. So if I break up 6, 6 is 2 times 3, so nothing's coming out of there. But I have 3 z's, so the z will come out. But I have to keep square root of 6. And what 3 numbers multiply to give you 125? It's 5. Cube root of 125 is 5. And for C, I'm looking for 4 of a kind. 2 times 5 is 10. I don't have 4 of anything there, and I don't have 4 of enough A's. But I can take, so I'm going to break up 4th root 10a squared. And now, do I have 4 of anything in this problem at all? Well, 81 is 9 times 9, and 9's are 3 times 3. So I have 4 3's, and I have 4 4's. So that's the only thing that can be done. I have to leave the numerator alone, and the denominator was the only thing that you can simplify. So we are going to finish these bottom ones. For 21, I don't know what the square root of 13 is, so I'm going to leave it as square root of 13. Square root of 49 is 7. For 22, I can break this one up. Cube root of 27p to the third over the cube root of 8. What 3 numbers multiply to give you 27? That would be 3, and I have 3 p's, so that p comes out, and I have 8, cube root of 8 is 2 times 2 times 2, so that is a 2. So 3p over 2. And for 23, I'm looking for 4 of a kind. I have 4 q's here, so that q comes out, and I have 4th root of 16 is 2, but I have to leave the 4th root of 3. That 3 is the only thing that can't come out. Okay, 9. Example 9, some more division. Now, another thing you can do, if the indexes are the same, these are both square root, you can simplify this. 6 goes into 24 4 times. And 1a here cancels with 1a here. So this becomes a squared. This a cancels with an a here. So really this problem amounts to 4a squared. So now I'm looking for 2 of a kind. I have 2 2's and an a. Okay, you can do it with any as long as the index are the same. Okay, so here we go. And it's easier to simplify first before you break it up. So for this problem, 2 goes into 54 27 times. So I have negative 2 cube root 27 now. And this 1a cancels with 1a here. So this now becomes a to the third power. So now, what 3 numbers multiply to give you 27? That would be 3. This equals 3. And this would just be a. So 3 times negative 2 is negative 6 over a. Okay, and we are not going to deal with the negative exponent. You have to move it, and technically we don't even have to do cube root, so we're going to leave that. We're going to do 24. 24, what I would do is simplify this. 3 goes into 12 4 times. So the 3 is gone, and a 3 that was in there is gone. 1a cancels with, we now have 4. So I'm looking for 2 of a kind. That'd be 2a squared. Okay, and we can skip 25 and 26. Last problem. What do you do when you're multiplying radicals in the indices, the indexes, are different? So we've looked at all the problems where the indexes were the same. They were both square root, cube root, and so forth. So this is getting into more information that you're going to learn in the next class. So you can't multiply you can't say, since the indexes are the same, you can't combine these. So what you're going to do is turn this problem into 8. The base is 8. The radicand is 8. This becomes 1/4 power. This becomes 5 to the 1/3 power. So the indexes are the denominator. So what you have to do now is you have to get a common denominator. So you're going to turn these into power of 12. So this is going to be 8 to the 3/12 times 5, and this is a 12 4/12. Okay, so now what you're going to do is look at this problem as the index is now 12, so it's the 12th root of 8 cubed times 5 to the 4th power. Now if you multiply 8 cubed and 5 to the 4th, you get 320,000. So it's really the 12th root of that. That's the only way you can do these problems, is know how to translate it from a radical to a rational and then get a common denominator. So that concludes section 9.4.